Today's session is part of a series of demystifying events that we have put together over the last 6 months. These sessions are designed to help unravel and demystify some of the key technologies that businesses need to be aware of, understand, and ultimately invest in on their journey to net zero. This webinar also forms part of a wider suite of services that we provide to businesses to help them reduce their carbon footprint and decarbonise. So in addition to today's webinar, we've also got services such as energy audits, a grant programme, peer-to-peer learning, net zero training, events and networking, and also help to link you up to a local network of suppliers. So if you're not already engaged with the team, then I encourage you to do so, and we can talk about how we can support you. Okay, so the objective for today's session is to build people's understanding of heat pumps within a commercial setting. Over the course of the next hour, we'll be taking you through a series of topics. We've decided to try and keep a fair bit of structure to allow us to cover a nice range of topics to give you that full view of heat pumps. So over the next hour, we're going to be covering the technology. So what is a heat pump and how does it work? Suitability, when is a heat pump right for your business? Designing a heat pump system, how we can make sure the system we design is fit for purpose and performs to plan. Building the business case, so securing investment, what are the financial and other considerations businesses must be aware of. Installation, so a typical run through of the process, the preparation before and installation of the actual kit, and also touch on some of the operations and maintenance considerations, so aftercare requirements, essentially, how to get the best out of your heat pump system. There will be time for questions at the end also. Helping us to guide us through these topics, distilling the knowledge of heat pumps, I have two of industry's top experts with me today. So we have Charlotte Lee, Chief Executive of the Heat Pump Association, and Andy Louth, Managing Director of Groundtherm. Just to add, before I introduce my two panellists, the session is being recorded, so it'll be made available to everybody after the session. We do have time for questions at the end. So if you leave a question in the chat, my colleague Tim will come on and ask those questions of the panel members at the end of the session. And just to say, we're approaching this with an assumption that people have a limited understanding of heat pumps. So it's less technical, more lay. And the idea behind that is that we don't leave anyone behind. But if you are particularly into techy detail, or you're maybe further on in your heat pump journey than others, then please ask a technical question and we'll fire them at Andy at the end of the session. Okay, right, if we could get stuck in then. So Charlotte, Andy, if we could have a quick overview just in terms of just a hello from you and a little bit about your respective organisations. Charlotte, if I can come to you first, please.
Yeah, hi Catherine, thank you for having me on. So I'm Charlotte Lee, Chief Executive of the Heat Pump Association. So the association represents heat pump manufacturers of ancillary parts, heat pump installers, consultants with an interest in heat pumps, and certification bodies as just some examples of the members that make up the association's membership. And in general, our raison d'etre, I suppose, is to support the deployment of heat pumps throughout the UK, all types of heat pumps, as and where suitable, and we work very closely with government officials on developing policy to support that deployment, but also on supporting the installer journey through guidance and training, and also looking at how we can better support consumer information as well on what a heat pump is and the benefits of such.
Perfect, thank you, Charlotte. Andy, over to you. Brief intro.
Yeah, okay, so my name's Andy Louth and the company's Groundtherm Limited. We've been installing for the last 24 years. Basically, we're an installer company. We do from domestic to commercial. I'm part writer of the new Trailblazer MVQ Level 3 apprenticeship, which is hopefully going to be launched this year. Sit on Ground Source Heat Pump Association Council. But been involved in the industry long enough just to understand how things should work and obviously how we can use other reclaimed energy that you're already producing from your commercial products. But anyway, okay, that's a brief one on me.
Thank you, Andy. Okay, let's kick off then. So introduction to heat pumps. Charlotte, do you want to just start by giving us a sort of a nice scene setting, sort of background to heat pumps? Like, where are we now? Where do we need to get to? Why do we need to decarbonise our heating systems?
So in terms of decarbonisation of heating, currently, as it stands today, heat accounts for over a third of the UK's greenhouse gas emissions, and that heating is supplied to 24 million homes and businesses and industrial users that are currently connected to the gas grid, and that will need to change if we are to meet the government's net zero commitments and to align with the Climate Change Act. So the government have committed to be net zero by 2050, and in order to meet that target, it will require, no doubt, it will require the decarbonisation of nearly all heating buildings and a large proportion of decarbonising heat from industrial processes too. And heat pumps have a vital role to play in that process of decarbonisation, and that's through the electrification of heat, because decarbonising electricity is easier than, well, it is possible, especially through the renewable deployment that's we currently see in the UK through the wind and solar, and that will ramp up as we move forward. So really focusing sort of in this sense on electrification of heat, of which heat pumps operate in that space.
Yeah.
And I guess if we look at sort of the overarching, why do we need to do this? You know, we can take this right back to the need to slow down the rise in global temperatures and the impact that has on the planet and the environment in which we live. But down to this level, in terms of businesses and what they can do, you know, the government have set an ambition to reduce business energy use by 20% by 2030. So that's seven years away. And the government are doing things to support and incentivise and really sort of focus, I suppose, business minds on their on their energy usage. Yeah. So the requirement of the energy performance certificate to be, you know, publicly displayed on business premises if it meets a certain floor level, or if the business is visited by the public, or if they've got one for any other reason, you know, it needs to be on display. And in terms of the type of heat pumps that can be used in commercial and non-domestic settings, any heat pump can work in a commercial setting. So ground source heat pumps, air to water source heat pumps, air to air heat pumps, water source heat pumps, a combination. It's the equipment size that would change, not the technology in itself. And ultimately, you know, Andy will be able to provide some sort of in-use examples of this, but the best heat pump for a particular building will ultimately come down to the space available, the initial capital budget, the usage requirements from the users of the energy within that building, the heat and hot water demand within that building, whether there's a need for cooling as well as heating. So it really is dependent on the building type.
And we'll get into some of that, I think, in one of the later sections. So thank you for that, Charlotte. So Andy, do you want to give us, if you can, in layman's, a brief intro into how a heat pump works? I see you've come prepared there.
Yeah, I mean, basically, let's firstly start. We're not looking with a new technology. This technology's been around since the 1853 or thereabouts, when Lord Kelvin made an heat pump. The bad thing about that, he made a fridge. And in them days, we required more chilled fuel than we actually did require any sort of heating, shall we say. Yeah, so the refrigeration cycles obviously never changed dramatically since it was ever come out. And what we need to do is take energy and then magnify that energy from. So if we've got an electrical use, that supply of electricity, we need to magnify that through that energy in through what we draw through. If we had an air source heat pump, through the air temperature, pull that over the evaporator, put that in through the refrigeration cycle, squeeze that gas, and then on the other side of it we have a hot gas. Based on that sort of factor, it's whatever we can use it for on the other side of that. So the process is either for heating and hot water, or we can use the other cycle of it for chilling as well, based on the back of that, and we can adapt it through other energies. So like if we had a water source, ground source, where we had an open loop system, and we had continuous temperatures coming in of, shall we say, 10 degrees or 12 degrees of water coming in, yet again, we're looking at using that energy through the refrigeration cycle and processing it into quite an efficient system. So the old phrase of 1 kilowatt of electric and 4 kilowatts of output is something that we want to look at to produce an efficient system. You know, gas condensing boilers around about 90% efficient. You know, nominally we would like to look at something around about 3.7 to 400% efficient on what we call a COP, coefficient of that performance. If we had an air source on a bad air day, shall we say, -2 outside, with some of the new air sources that can produce around about 300% efficient. But on an average, that's what we're looking to try to do. We're going to produce efficient from electricity, and we're not going to burn any fossil fuel in that process of doing that. And that's what this is more about, decarbonising the grid, as opposed to, you know, burning more fossil fuel.
Yeah, okay. Thanks, Andy. Okay, so just moving on to suitability then. So how we understand whether or not a heat pump's right for us as a business. Charlotte, can you kick off by just giving the delegates just an overview of the benefits of a heat pump that businesses should be aware of if they're looking to consider investing in one? What the benefits are?
Absolutely. So Andy's just given a really good overview in the sense of the efficiency of a heat pump in terms of the usable electricity versus the energy output. And I think that is, you know, one of the main selling points for a heat pump is that they can produce heating and cooling very efficiently. And therefore they have the potential to reduce the business's heating and hot water bills because of that efficiency rating. They can also support a business's commitment or drive towards demonstrating their commitment to reducing their carbon emissions. As we move more towards businesses focusing on the environmental, social and governance, so ESG perspective of what they're doing and how that what that looks like compared to others. We know that investors are looking at those requirements more and more now. So from that side of things as well, they can help with the reputation of a business as well as providing efficient, lower cost heating.
Brilliant, thank you. So Andy, I guess then if I'm a business that I need to heat and cool my space, I want to reduce my bills, I want to support, I've got carbon ambitions that I need to support, it feels like it's a match then for a heat pump. Is it as simple as that, or is there suitability requirements that we need to be aware of, factors that a business needs to consider to get to the point that they can you know, categorically say that a heat pump is right for them at this point in time? What advice would you give?
The lot of suitability is a very varied area for suitability. Shall we say that we got to see if it fits the boot? If that foot fits the boot, then we need to do a look at what you've got and make sure that the design aspects of it fits what you require. You know, obviously at this moment in time, beating the price of gas is very difficult, but a lot of businesses have got, shall we say, unused energy that you can reclaim for a heat pump, using that over an evaporator system, shall we say. Recently, I went out to a building that did it did printing, but it needed to keep the ink hot, but at the same time, it needed to keep the cooling process. But we used their VRF unit, which is an air conditioning unit. We reclaim the heat off that for the system, and then we had a higher efficient system over the air source to produce heat in hot water, and that's the sort of process we need to look at first. Firstly, what's the process that you're looking at? Have you got PV on the roof? In other words, are you producing electricity that you can offset by using a heat pump on to run, so we can run our inverter at different sorts of compressor speeds? You can get heat pumps now that'll go in an off-grid mode, and it'll use half its compressor output to make sure that we can maximize the output off the PV at that time. So it's understanding that company's process of what they want. Domestic properties, it's very easy to understand. We need to produce heating and hot water. Although these days we are now looking at the portion of cooling as well. If we use a natural cycle off a ground source, we'd be able to produce passive cooling from the ground array. And that passive cooling is basically free energy from the ground that we need to produce. Plus also it improves the efficiency of that ground source heat pump on its return temperature. So it's understanding what the building looks like, what the requirement is, and then understanding what that carbon reduction is going to look like once you've made the application for that process. And that can all be done by design, and designed the key aspect of all this, and making sure that your client understands what they're going to get at the end of it.
And in terms of understanding some of those factors that you've just set out there, do you think within a business's gift to be able to do that, or is that something that they need to bring in an expert?
Well, I'd always suggest that, you know, basically you do your own survey first. So then if you do bring somebody to the table, they've got a clear outset of what you would be looking at, and understanding your requirement. Okay,
thank you. And Charlotte, just around building type, so archetype, does that have an impact, or age of the building, does that have an impact, or is that a bit of a misconception?
I think that the age of the building comes or is used as a point of discussion, largely because generally speaking, the older the property, the less sort of energy efficient that is. So it's not right to say all old properties would not be suitable to have a heat pump. It is correct to say that heat pumps generally work better in more efficient buildings to reduce the building's energy loss, and therefore you can size the heat pump be smaller, and ultimately it works better in that sense. So there will be an assessment on the sort of energy efficiency of a building prior to the sort of installation of a heat pump, but that would all be incorporated into the design and surveying stage that Andy was just discussing as well. So it's not the age of the property, it's the energy efficiency of such.
Yeah, get you. Okay, brilliant. So if we could talk about design then. So we've decided that a heat pump is what we want to go for. So we now need to design the system. And if we want to make sure that it's a well-functioning system, talking to you both, you know, there's a lot of work that needs to go into this stage. So Andy, if I could come to you, can you try and set out what, like, in terms of the key factors that we now need to sort of take into consideration and be aware of when we're coming to design, what goes into designing a well-performing heat pump system?
So obviously, like I said, it's understanding what this building looks like first. So let's say, for instance, we're looking at an area where we've got an office and we've got a working space as well. Quite a lot of ideas come forward with that, and that is firstly understanding the heat loss calculation of that building. Heat loss calculation is a major trigger point for this, and then once you've understood the calculation of that building with that heat loss, and that's down to age, like you said, insulation levels, solar gains that we've got in the property, and understanding what the mass flow rate is going to be in that building. And the mass flow rate really is your heat output from your emitter system.
So like your radiators? Yeah,
like your radiators or a blown air system. How these people want to move heat through the building on hot water. But making sure that you've got this infrastructure in place first. There might be a point where if you've got a lot of solar gains, you might want to put some passive cooling in there as well, you see, into big glazed areas, which a lot of office blocks have, and then reclamation of heat from other areas, so ventilation might be into that process at the same time. Blown air systems in bigger buildings normally work a lot better than your standard sort of convection radiator system. And obviously understanding the way that that ventilation system will work with your heat pump based on what the demand is. So yes, heat loss calculation first. If we fit in a ground source, then a British Geological Survey and a ground loop design would need to be put in place. So in other words, the abstraction of heat that you're going to require to pull from the ground.
Yeah.
So that ground is built up of different strata levels and what we call the aluminosilicate. Them silicate properties produce different watts per meter Kelvin. In other words, they have an output that you can draw off. And then once that size designed for the ground array based on the kilowatt running hours of the system, because it's quite key to understand how many kilowatt hours a system's going to run. How long is it going to run for? It is about the peak demand of the building from your heat loss calculation, but some systems might run longer. So if you've got a system that's running 24/7, it will run longer as opposed to your standard domestic property, which commercial properties have a higher demand, and we need to understand the production side of that commercial property. So heat loss calculation, and then a design based on the ground loop temperature. If you're going to have a ground, if you're on an air source, we need to see if we're in Scotland, it'd be a different occasion to somebody's down in Hampshire. So we need to understand whereabouts in the country you are based on the air temperature. And then that's the way that you sort of size that air source, you size that evaporator to make sure that you've got that coverage through the winter months. And then after that, you need to size your system to put it into the property, either, like I said, radiators or even a blown air system, how you get that in there. And then really, after that, really, your design should be pretty much sewn up.
In terms,
can just come in there. One key thing as well is to make sure that the E&A applications carried out for the DNO, the district network operator. Your E&A application is your electrical network application. It's down to them to make sure that you've got enough, shall we say, juice into the building to supply that heat pump. Yeah,
and that is a prerequisite. So that needs to be in place before an installation can.
Yeah, once you've got an average size of that building, what its output's going to be, then you need to make that application, because if they reject your application, you could spend a lot of money on design and everything else first. So just make sure that that's in place first. And
you mentioned that's the geological survey as well. What can you just explain that briefly?
Yeah, so geological survey is normally done by a consultant. You can probably look on the GSHPA for consultants that do ground source loop designs. I mean, there must be other ones out there that I don't know about, but most of the guys that do that are on there. So if somebody was going to look for a ground loop design, then I'd be looking on the GSHPA there to see what that ground loop design looks like. You can do a desktop survey if you wanted to, and if that designer was happy with that desktop, then that's fine. But if not, then you can do what they call a TRT, which is a thermal response test, and that TRT test will tell them what the ground's going to give you back in how many, within its energy and how long for.
Yeah, so it's not a case that those surveys will come back and say it's not suitable to do ground source. It's just it would help inform the calculations that would drive the design.
Correct.
Is that right?
Yeah.
Okay. So those surveys and applications would be at the design stage that you get all those together.
Yes, normally your designer or your installer would sort of help you make them applications and really hold your hand through the process to make sure. You might have an installer that doesn't do a ground loop design, but then they'd need to work alongside with the designer for that, for the ground loop design, to make sure that they're all on the same page. And then at the same respect, you'd need to work with a driller, or if you was going to have a horizontal, that machine driver, etc. So understanding that process of, you know, you've got to get this stuff in the ground. You've got to make sure that the driller knows what he's doing as well. And we all get the right outcome from that.
That sort of leads on to a question around sizing and spacing. So obviously, is this a domestic system behind you? But like, can you just give us a sense of? I know it's probably how long is a piece of string here, isn't it? But just from a like, can you just give us a sense of what size, like the internal part of a system might be, and also the external if it's an air source?
Yeah, so if there's, you know, if this was a commercial one behind me here,
yeah,
obviously this is just a standard 40 kilowatt system behind me. They're, you know, they're only small heat pumps, but if we was looking at obviously maybe a 500 kilowatt system, probably maybe 3 times the size of this. But a lot of guys now, like myself, are putting them in containers. So we're containerizing the heat pumps, which is good for servicing, and you know, it's good for, like, shall we say, it's standalone, it's away from the building, and you know, a 20-foot container would probably do a 500 kilowatt system. Anything bigger, then we need to look at other areas where we need to go to with it. But most commercial buildings do have a good size areas, but we all know that space is key.
Yeah, and is there anything around noise or anything that needs to be a consideration if depending on where that business is sited?
Yeah, I mean, there is a slight noise with the systems. You know, obviously we've got compressors that are going to fire up and run. Not as noisy as they used to be by any means, but that's why they end up being containerized, just to keep the noise down. But I'll be honest with you, if it's a workshop,
It's noisy enough.
It's yeah, it won't build above any noise in a workshop. Obviously, an air source has got moving parts like a fan, and you'd have to make sure that that you're within regulation for that as well. A little bit different for commercial than it is to your standard domestic, but most commercial ones, you have plenty of area outside anyway.
Yeah. Okay. Brilliant. Okay. I should say that other products are available. Hey Andy, I can see the Valiant you've got behind you. Yeah.
Yeah, I'll share some other ones if you.
Nice segue, Charlotte, to a question I was going to ask you really around the multitude of products that are on the market. I know that the Heat Pump Association represents about 95% of the manufacturers, I think I saw on your website. So just from a business point of view, have you got sort of advice on how they'd make sense of like what product would suit them and suit their requirements?
So in terms of the heat pump products that are available, I mean, Andy said that there are lots of different options, and really it depends on what the customer wants. So what they need from the heating system. Is it just heating? Is it heating and cooling? The size of the property as well, in terms of the suitability of the requirement. So I think really it will come down to space available, budget in terms of the upfront capex to fund the installation, and the usage requirements for that building and for that business. So in terms of how that's specified, you know, ultimately it's often left to the designer to decide what system would suit the needs of that customer best. And I think, as Andy said earlier, you know, it's really important for that business prior to getting that survey and engaging with the designers to really think about what they're trying to achieve by swapping or installing their heating and hot water system. Is it just heating? Is it heating and cooling? And what their demand looks like? Is it higher in certain months, typically over the winter, but generally speaking, what that usage looks like, and also having an idea of their current usage pattern as well, will be really important prior to engaging with that designer as well.
Yeah, great. Okay. And I don't know if we're able to give a sort of a sense of typical cost for a typical heat pump. It's another how long is a piece of string question, this, isn't it? But have we got a range in terms of how much a heat pump sort of costs are you seeing at the minute? with clients?
Obviously, an air source heat pump is, shall we say, a third cheaper than what it will be for a ground source. You normally find that drilling costs on an average is £50 per metre for the drill. And then obviously you wouldn't have that with an air source heat pump. The ground source size is equivalent to what an air source side would be. Same sort of scenario, cylinder and buffer tanks and install facts.
Yeah.
It is all dependent on size of building. You would be in the same sort of situation if you was trying to describe a gas boiler.
Yeah.
So at the end of the day, it's all down to the fit. But I would say, make sure the consultant up front understands what your requirements are before you just go ahead and fit, or you just go ahead and say, I'm going to call 10 installers around and get a quote off everybody, because you need to know what your requirements are for first, you know. But I'm very sure that this kit in the future will become cheaper as our Chinese market expands.
What about payback then, Charlotte? Are you?
So in terms of payback, I think the challenge remains that Andy just put forward. But what I would say is, and we've raised earlier, in terms of the efficiency of a heat pump compared to a gas boiler, for example, you know, we're getting 300 to 400% efficiency ratings there. Now, what we have found, and businesses will know, obviously the price of electricity relative to gas is higher, and it's higher than it has been historically too. Now, in part, that is because of environmental and social obligations, or what some people call green levies, that are put disproportionately onto the electricity bills rather than the gas bills, and the government have committed to looking at that and looking at rebalancing those costs to effectively support the electrification of heat. So we are expecting a consultation on that soon. Having said that, at efficiencies of 300 to 400%, there are still cost savings to be had through the installation of a heat pump, and they are vastly improved if you've got solar PV and battery storage in place as well. So there are, you know, it all depends on what your usage, your demand is, and whether you've got support from other systems for the electric generation as well. I suppose if we look beyond the pure financial as well, there are other reasons to consider, you know, decarbonised heating in businesses. And I touched on it earlier, but recent evidence is showing that stakeholders are increasingly informing their purchasing decisions, but also investors, their decisions as well, based on a company's environmental, social, and governance credentials. So I think there are other benefits of looking to decarbonise a business's heating and hot water demand too, and the growing interest in BREEAM, so which is the Building Research Establishment Environmental Assessment Method, which is used to measure a building's environmental performance, is also sort of becoming more prevalent as well, and heat pumps can be used to maximise that output too. So there are financial savings to be had from heat pumps on heating and hot water bills in terms of costs, but I guess also on reputational advantages too that I think are important to consider.
Yeah, it's I think Andy and I talked about this last week. It's future proofing, isn't it? You know, not just from an energy security point of view, but about reputation, sustainability, resilience as a business in general.
Yeah, because that resilience, let's look where we might be in the next 5 or 10 years. Because the idea at this moment, we're ruled by gas powered turbines that produce electricity. Like I say, as we get more onshore electric wind turbine, I'm very sure that will come back into the fray of it again. Then the gas, you can buy low on gas and sell high on electric. Once they start to move forward with doing more electric, and the price of electric stabilises, then that levy on gas will start to rise, and you'll find that your electric will be cheaper.
Yeah.
And that's where the aggregators are looking for anyway at this moment in time. So we need to look at what the future proofing of what we look like, not the right here and now.
Yeah, brilliant.
Planning's key.
Let's move on. Just conscious of time, so if we just cover off in terms of installation and then a little bit on operations and maintenance, we can move to questions. So I think from an installation point of view, we've covered off some of the sort of preparatory stuff that you need to do. So you need to apply to the DNO with an E&O form. You may need to have done those surveys. Is planning requirement in a non-domestic setting?
Yeah, now planning requirements sometimes based on down to your local council on what they're looking at on a planning requirement. It's usually to do more with air source than it is with ground source. You'd have to show there is other things with ground source, like, you know, checking with the local coal authority and obviously the Environment Agency to make sure that you're not going into any aquifers or dealing with any sort of coal mines that are out there. But normally coal authority will give you a good idea of what's out there, and they're very knowledgeable on what they've got through that authority. Environmental Agency will always give you good information on what you might be drilling. You know, if you are doing a ground source, this is what you might be drilling through, or where you might be digging, shall we say. There might be newts and things like that in the area that needs to be protected.
Yeah.
Now coming back to an air source, obviously that's all down to sound and that sound barrier, just to make sure that, you know, if you are, even though commercial but near residential, it's always good to check with planning first, just to make sure that you've covered them sort of areas. Other than that, normally it's a fairly reasonably simple process. There's not great barriers to jump usually. It all depends on where you are in the world. You know, if you was next to the palace or something like that, you might struggle. But normally on commercial properties, it's never a difficulty. You know.
Yeah. Okay. And typically, then, how long does an install tend to take?
On size of install, obviously, yet again, but sort of between, shall we say, 2 weeks to 6 weeks. Now, if it's a larger install, which some of them have been, we can take up to around about 2 months to do the job. But them are on the larger install, shall we say. Yeah.
Okay. And Charlotte, just a final question on this section. In terms of picking an installer, any advice on what a good supplier would look like that a business should be sort of looking to work with for a project like this?
Yeah, I'm conscious that business encapsulates so many different size properties. So, you know, some of the businesses that may be on this call or considering heat pumps may be more akin to sort of a domestic setting rather than a large commercial, in terms of what Andy was talking about with time frames. So, you know, generally speaking, anything up to 45 kilowatt thermal, we recommend using an MCS registered installer for heat pump installs, and they're easy to find on the MCS website. In terms of the much larger projects that get, you know, the detailed specification, the detailed designs, invariably there'll be a tender process and an evaluation through that in terms of what you set as your selection criteria and the weightings of such. And I guess we would always suggest to identify contractors that have delivered similar scale projects before, so have experience in this space. And you may well find that the designers have a project partner that they know and trust and work with. But I think, you know, it's all around making sure that you as a business set out, you know, key criteria as to what you expect from that installer, and then you know, score appropriately, I suppose, to make sure that you get somebody that you trust and will do the job that you want them to do.
Yeah. Okay, well, Andy, just to ask a couple of questions then on operations and maintenance then. So I think you were saying that typically an installer should always do a decent handover of the equipment and the system, so some training to for the operatives. What in your mind, are there any what does the maintenance schedule look like? Is it?
So, I mean, it's like recently, you know, we've just handed over one now to a care home, but they've got like a maintenance chap on site.
Yeah.
So on our handover, we've run through with that maintenance person. To me, I see him as a client because he's a man that we'll always meet when we get to site.
Yeah.
But basically, he needs to understand the mechanical side of it, what he's looking at in front of him. If there's any issues, can he isolate? A lot of heat pumps now are online. So a lot of the heat pumps that we have online, we can monitor from where we've got. We can see if they're, a lot of heat pumps when they're firing up for the first sort of 3 months, especially on a big ground loop design, you'll have certain flow issues just to make sure as things settle. And all the time you can sort of look at it, monitor it, see what the hot gases are doing within the refrigeration cycle. You can go online a bit more in depth with an heat pump than you could with sort of like your relative gas boiler sort of scenario. But basically handover is quite a key thing. Giving that documentation, letting that client understand what they've got, and when you give them the online process, it's good to keep with them for at least, well, some of my clients probably 3 years, but just to keep revisiting and making them understand that online process, what we're looking at. So yeah, that and servicing. So servicing's all depends on what. If it was an open loop system, then if it was an open loop ground source, shall we say, then there'd be, if there's a maintenance man there, he would maybe need to backwash or clean the filters on the open loop side of the system. He may need to do that once every 3 months, but standard, it's normally just a normal once a year service. Check filters, check brine quality, check that the air source hasn't got any debris within the evaporator, and just make sure that everything else is right, and no wraps have been chewed through any cabling or anything like that, or nothing's been damaged, if it's in a workshop scenario. So normally just standard once a year. If there's a maintenance man on site, just make sure he understands the whole system and what he's got.
And presumably the more you can do in that respect, it'll increase the lifespan of the system itself.
Yeah, exactly right. And look, basically these systems are hermetically sealed, shall we say. It's a sealed system. If you're getting particles, debris in your strainers, then you'd need to check your system, because normally that's sort of eradicated any of them sorts. If a brand new system's done, normally within that first 2 weeks to 3 weeks, you're cleaning the filters, just checking it's running fine.
Yeah.
But if it's a closed loop ground source, you need to keep an eye on your brine, or shall we say glycol, heat transfer fluid, whatever anybody wants to call it, just to make sure that the percentage is correct within that refractometer setting, just to obviously make sure. Yeah, so it's just check the glycol level really in the system, really. Yeah.
Okay, brilliant. Right, I think that concludes the questions. Thanks for that, Andy. Tim, do you want to join us? Have there been any questions from the chat that we can ask in the last 10 minutes?
Afternoon, everyone. We have had a few questions coming through. So we'll start with this one, which was pre-submitted. It's from Will Clark. He'd like to know, what are the main barriers that a business will see when it comes to installing a heat pump, and how do you overcome these barriers?
So, to be fair, there's not many main barriers. One of the, obviously, as you can see behind me, one of these, make sure that you've got a good enough area. There can be restrictions with, if you had an air source, shall we say, where about outside on that building you can locate that air source. Always one slight restriction is the logistics of getting the pipe work into the building. You know, if you've already got a building now, do we need to look at putting the pipe, if the air source is away from the building or the ground source, are we going to run it under the tarmac? Are we going to run it under the flags? So logistics and pipe work, make sure coming into that building is quite a key thing. And then any sort of alterations you may need to make in that building, shall we say the emitter system, the radiators, or the way that we want to produce that. It's like now we're doing an office block now. What they require heating and cooling. We're going to provide passive cooling from the air source, but we're switching all their radiators over to fan coil systems. As long as they're aware of that, based on that design that you put together, then you know, as long as people are shall we say acknowledging the client to make sure that they understand what's going to need to be done, and that's down to your consultant or installer to make them fully aware of what the application should look like.
Yeah, and what disruptions they might expect or need to expect.
Yeah, because you know you've got a building that you're going to disrupt, and it's not a boiler that's hung on a wall.
Yes, okay.
The other consideration, Catherine, in that sense, is making sure that the building owner and the business using that property, because in some cases the businesses lease properties, so you know the decision making in terms of the heating and hot water system may not lie with the person using that system necessarily. So it's ensuring alignment and you know communication between the two parties to enable you know a satisfactory outcome on both sides of the equation.
Yeah, and as early as possible, I guess that the business engages with their landlord to start that conversation, the better.
And then there's the one big key is that if the insulation levels aren't correct, you know, get your building up to insulation levels first, before you fabric first every time.
Okay.
So.
Thanks, Andy. Tim?
Yeah, we have a question here from Chris. He'd like to know, after the initial installation, how soon would you be able to see a return on investment from your heat pump? So thank you, Chris.
So that's all down to basically what energy you're burning first. Just understanding firstly, so some of the properties that we go to, they're on LPG or they're on oil. That return on investment is pretty rapid. Some of them within the first 3 years. If you're on gas, it's going to be difficult to find a return on investment. But if you're utilizing your energy that you've got already, like I say, reutilizing some of the systems that you've got, you'll have that return on investment. The one that we've just done recently, where they're on gas, but we've reutilized their energy that they're producing from their, shall we say, their manufacturing process. Its return on investment is 6 years. So you can make it faster by reusing their energy.
Great.
And of course, with PV and batteries, as we've said as well, that supports that payback period.
Helps to offset it. Are there any others?
Yeah, we've got another one here from Mark, which is, what sort of information should be in a quotation from an installer? And other than price, how do you decide on which installer to go with?
It's difficult, that. So basically, you're going to want to know, firstly, if you've got a consultant involved, what he's actually going to consult on and what the advice is that he's going to give you at the end. And it sounds a bit strange saying that. So really, consultants need to be a little bit more multifaceted. You know, if you've got a ground loop designer, you're going to need somebody who understands what the building heat load is going to look like. So you might need to have 2 consultants, one for understanding the building workload, and one for understanding what the ground loop side looks like. Your installer would, if it was an air source, would probably go back to the manufacturer or work alongside the consultant to make sure that that's sized right. So basically, your install side is about what you're installing, what the function of it's going to be looking like. In other words, are we installing a ground source? The driller's doing the drilling. We're doing the header works. We're installing the ground source, the buffer tank, the hot water cylinder. We're the guys that are going to commission the system, and we're the guys that are going to maintain it. So down to maintenance, that's what should be a part of that quotation. Picking an installer, there is places that you can go to do that, but I think the question is asking the installer, have they done this sort of size project before? Now, not a lot are doing it, because a lot of them are busy with domestic properties. But if you can, and you've got a good consultant, normally good consultants work alongside installers that do them sort of size systems. It's very difficult to find one that does commercial. And
I was just going to add to that, if Mark is local, obviously we've got local suppliers such as Andy on our marketplace, and when we work with businesses, we do try and capture information around how long they've been installing, so their demonstration of experience effectively. So if we can be of any assistance to help with that, then give someone a shout after this. Tim, are there any others?
Yeah, there are a couple more. We still have time. Charlie would like to know, Andy, what is your opinion on hybrid heat pumps?
so if you're talking hybrid with, I've got to try and understand what you're trying. So is it a hybrid with a boiler, or is it a hybrid ground source and air source combined? So yeah, hybrid system with a boiler. Yeah, I fully understand there might be a purpose where that heat pump might not be able to do the function what the boiler is. But some of the new heat pumps that are on the market, the technology's ramping away rapid in respect of commercial side of it. We do have a guy who's Ken Neal, who's got heat pumps that can produce steam. So and the way, and that's because of the function of the way that the new gases are coming out with, some of these are working with ammonia now. But in other words, what I'm trying to say is that you can do away with the boiler. Personally, I think if you go the whole hog, you go the whole way. What you can do is have a ground source and air source hybrid system. So you can use your ground loop temperature. And the ground loop wouldn't need to be the full size of what it was before, because you're going to use the evaporator from what we call a dry air cooler. So on a day like today, where we're seeing outside temperatures of around about 15 to 17 degrees, that dry air cooler is more efficient than your ground source. So you sort of use that side of the system to produce your hot water demand or a production demand for heating. And then in the winter time, when we probably say maybe 6 weeks to 2 months maximum of 2 degrees or 3 degrees external, then it would use proportionally more of the ground source side than it would the air source. The advantage of that is you don't need a big ground array design. So if you've got a small portion that you could use, and it wouldn't be enough to do the full load of the building, then you could adopt an evaporator in there, and that's my sort of idea of that. Does that answer the question? Right. Okay.
I think so.
So good. There's one last question from me, which is more of a domestic focus rather than a commercial one. But Laura would like to know what needs to happen to improve accessibility to heat pumps, and when can your average household expect to be able to comfortably afford one? So more of a domestic focus here, but if anyone would like to take that one.
Charlotte?
Yeah, so I think in terms of domestic, there's more sort of financial support options out there than commercial at the moment. So the boiler upgrade scheme provides upfront grants of £5,000 for air source and £6,000 for ground source heat pump installations, and they are open. That is accessible for non-domestic properties as well, up to 45 kilowatt thermal. So it's the size band that restricts applications to that scheme, although only 53 vouchers out of 11,800 have been redeemed for commercial properties. But in terms of domestic use of heat pumps, there is that upfront capital cost contribution from government that can be claimed. And more widely speaking, I think it goes back to the price of electricity and the function and the impact that will have on sort of the economics of a heat pump system. Whilst the efficiencies of heat pumps at 300 to 400% will demonstrate a return on investment as opposed to gas, it depends on the usage as well. And I think there is work the industry need to do in terms of recommending and sort of impartial advice to consumers on usage of heat pumps, because they are slightly different to typical use of a boiler. And in order to get the best out of a heat pump, it's a low and slow policy in the sense of leave it on 24/7 at a lower temperature, so you're still feeling the same warmth, but it's not the blasts of hot and cold that perhaps you're used to. I know when I was younger it used to come on at between 6 and 8 in the morning, and then between 3 and 8 at night when we were using the house, and that's a change in how that customers would use their heating system if a heat pump was installed. So I think the key points for domestic rollout and the meeting the targets the government have set. New build housing, the Future Home Standard is hopefully coming. We're expecting a consultation soon, so that should absolutely drive heat pump deployment in new build. And then for the retrofit market, there's the support for the upfront cost. And as we see electricity price reduce and perhaps gas increase, or just the rebalancing of those levies, it will be a much more financially attractive proposition to install a heat pump. Having said that, if you've already got solar PV on your roof, and I know I keep saying this, but we have seen a massive deployment of solar PV over the last 2 years, largely in response to this sort of energy crisis that we've experienced, then it absolutely makes sense now and should be something that is looked into.
Brilliant. Thank you, Charlotte. That's great. I think that probably concludes our session this afternoon. Thanks so much for Charlotte and Andy to taking the time to join us and to give us a great run through of heat pumps, what they are, how they work, how to get the best out of them, and hopefully see some of you soon investing in them.